Hey everyone, in this video we are talking about the remainder theorem and the factor theorem. So the remainder theorem says that when a polynomial function p of x is divided by a binomial, x minus a, then the remainder you get is equal to the value of the polynomial when x equals a. So you can think of the remainder as being p of a when x equals a. So that probably doesn't make a lot of sense, but that's okay because we're going to do an example. So in my last video, which was on dividing a polynomial by a binomial, I had this question. Z plus 3 dividing 3z to the 4 plus 6z cubed minus 18z. And I found that my remainder was equal to 135. There would have been an easier way to figure out if z plus 3 was a perfect factor, and that would have been the remainder theorem. So we're going to do the same question, just a different way this time to find the remainder. So the first thing I'm going to do is look at my binomial, z plus 3. The remainder theorem says your variable has to be equal to a number. Well, z plus 3, that's not representing my variable being equal to a number. So all I need to do is take that and say it's equal to 0. To get my variable by itself, I'll subtract 3 from both sides. Positive 3 minus 3 is just 0. So this will become z equals 0 minus 3 will be negative 3. And that's equivalent to x being equal to a. A is a number, x is whatever variable you have. All I need to do then is look at my original polynomial, which was p of x, and everywhere you see your variable, replace it by what you said that variable was equal to. So instead of 3z to the 4th, it'll be 3 times negative 3 to the 4th, plus 6 instead of z cubed, it'll be negative 3 cubed, minus 18 instead of 18z, it'll be 18 times negative 3. And when I figure all that out, it should be equal to 135, which is the remainder I found when I did it with long division. So negative 3 to the power of 4 is equal to 81. 81 times 3 is equal to 243, plus negative 3 cubed is negative 27, times 6 is negative 162. Negative 18 times negative 3 is equal to positive 54. 243 minus 162 plus 54, I get that equals to 135, which is exactly what I would have expected because when I did it using long division, that's what I found. So what that tells us is that this factor, z plus 3, is not actually a factor of 3z to the 4 plus 6z cubed minus 18z. And we know that because of the factor theorem. And the factor theorem says that when we let our variable be equal to the number that it was when it was dividing, we should get, when we plug in that number everywhere we have the variable, we should get it equals to 0. And 0 does not equal to 135, so we know z plus 3 isn't a factor. So let's do another example. We've got p of x is equal to 2x cubed plus 4x plus plus 6x squared plus 12. And I want to figure out, is x being equal to negative 3? That would be the same as x plus 3, because remember when we set it equal to 0 and subtract 3 from both sides, we would get x equals negative 3. So is x plus 3 a factor of this? Everywhere I see x, change it to negative 3. So I have 2 times negative 3 squared plus 4 times negative 3 plus 6 times negative 3 squared plus 12. I'll write my 12 over here because you guys can't see that. Okay, So 12 stays the same. Negative 3 squared is equal to 9 times 2 is equal to 18, positive 18. 4 times negative 3 would be negative 12. Negative 3 squared is equal to 9 times 6 is equal to 54, positive 54. Is 12 plus 18 minus 12 plus 54, does that equal to 0? That's what we're trying to figure out. I'll go 12 plus 18 minus 12 plus 54, and I get that's equal to 72. 72 does not equal 0, so we know that x plus 3 is not a factor of the polynomial 2x cubed plus 4x plus 6x squared plus 12.